Okay, in this lesson we're going to continue working with exponents, and we're going to talk about how to simplify multiplication expressions with exponents. So let's look at a quick review of exponents. So let's say we have 2 squared, and if you remember, that is the same as 2 times itself 2 times, so 2 times 2. And we know that 2 times 2 is 4. Well, what about if you have an expression 2 squared times 2 to the third? Well, there are a couple ways you can do this. You could work out each section. So you could do 2 times 2, which is going to be 4, and then multiply that by 2 times itself 3 times. That's supposed to be multiply there. So 2 times 2 times 2. We know that 2 times 2 is 4. 2 times 2 times 2 is 8. 4 times 8 is 32. So what do you notice? What do you notice in the second part here in this step? What do you notice right here? What are we really and truly doing there? Well, we've taken the 2 times 2 from 2 squared and multiplied it by the 2 times 2 times 2, 2 to the third, and now we actually have 2 times 2 times 2 times 2 times 2. So we really and truly have 2 to the 5th power in this second step. So the rule for exponents, one of the properties for exponents, when you're multiplying exponents, you can, as long as the base is the same, the base has to be the same or this doesn't work. As long as the base is the same, you can just simply add the exponents. So that's a neat little shortcut there. Now for this problem, it really doesn't save you a lot of work, but for some problems later on in your math education, this will come in extremely handy. So we try to learn about exponents early so that we can use them pretty much in everything we do from here on out. So let's look at one where it would be very difficult to do any other way. Now you could multiply this out, 663 times itself and then times this, but that's going to be a ridiculously huge number. But let's look at the instructions first. Express your answer as a single term using exponents. So they don't want you to work it out, so you got to read the instructions. They don't want just a typical answer. All right, so we're gonna use the properties that we've learned so far. The bases are the same. That's the key. If the bases are the same, we can do this. So the base is not going to change. This is really going to be 663 times, or squared times 663 to the 8th. So we can add those exponents, and we end up with 663 to the 10th power. And that is the answer that IXL is looking for, so that is simplified but not evaluated. All right, so let's try another one. This one would definitely not work in the calculator. These numbers would be so enormous that your calculator would actually crash. Well, not crash, but give you an error. So let's do this using the properties that we've learned. If you're multiplying and it's the same base, and I'm not sure why that all the examples I have use 663. I'm not sure if that was intentional on IXL's part or just coincidence, but it used the same ones. But the rules don't change regardless of the number. If this was a decimal, if this was a fraction, the rules would not change. The new rule that you just learned, if the bases are the same and you're multiplying, you can add the exponents. So up here, we just add 87 and 61, and we end up with 663 to the 148th power. Okay, that is an enormous number. But we can write it like this. And that is simplified using a single term with exponents like they asked. All right, what if they use multiple terms? Again, the rules don't change. As long as the bases are the same, and they are, we simply just add the exponents. In this case, we add all three exponents. And we end up with 663 to the 157th power. So even bigger than the last number. All right, again, so the rules are if you're multiplying two bases that are the same, you can add the exponents. And keep in mind that if a number is written without an exponent, it has an exponent of 1.